Pacific weather changing, impacts of rising multi-year El Nino and La Niña. Introduction. A recent study has raised concerns about the impact of human activities on the duration and behavior of El Nino and La Niña events. It found that the Walker circulation, a key atmospheric component of the El Nino Southern Oscillation, ENSO, has changed its behavior since the industrial era, potentially leading to more frequent multi-year El Nino and La Niña events. This article delves into the implications of these findings and the potential consequences of rising multi-year El Nino and La Niña events on our planet. Understanding the recent studies. The Walker circulation, a significant driver of global weather patterns associated with ENSO, has been under scrutiny. Researchers sought to determine if greenhouse gas emissions had influenced this climate-driving phenomenon. Their findings indicate a slight slowing of the transition from El Niño to La Niña over time. This suggests that multi-year climate patterns may become more frequent, carrying elevated risks of droughts, fires, heavy rainfall, and floods. While the overall strength of the Walker circulation has not diminished, the study raises concerns about potential weakening due to elevated carbon dioxide levels. Additionally, many climate models predict a decline in the Walker circulation by the end of the century. The research also identified a connection between volcanic eruptions and the weakening of the Walker circulation, often leading to El Niño-like conditions. Understanding the Walker circulation. The Walker circulation is a vital atmospheric circulation pattern in the tropical Pacific region of the Earth. It comprises winds that play a pivotal role in shaping climate and weather patterns, not only in the tropics but also globally. A weaker Walker circulation is associated with El Niño, while a stronger one signals La Niña. El Niño and La Niña, a brief overview. El Niño is a climate pattern characterized by the unusual warming of surface waters in the tropical Pacific Ocean. It can suppress monsoon rainfall in India and is caused by the weakening or reversal of trade winds in the tropical Pacific. Conversely, La Niña is a pattern describing the unusual cooling of the tropical Pacific Ocean, which tends to aid rainfall over India. It results from the strengthening of the trade winds in the same region. El Nino Southern Oscillation, ENSO. ENSO is a climate phenomenon resulting from the interaction between ocean and atmospheric conditions. El Niño and La Niña represent the warm and cool phases of this cycle, with episodes occurring every 2 to 7 years. However, multi-year El Niño and La Niña events, which persist for more than 1 year without returning to normal conditions in between, are rare but increasingly possible. Impacts of rising multi-year El Niño and La Niña events. 1. Increased frequency of extreme weather events. Multi-year El Niño and La Niña events can alter global weather patterns, leading to more frequent and severe droughts, floods, heat waves, cold snaps, storms, and wildfires. 2. Natural disasters. A. Floods and droughts. Multi-year El Niño events can amplify the risk of prolonged droughts followed by severe flooding events in different regions. Conversely, multi-year La Niña events can lead to excessive rainfall and flooding in some areas, followed by extended periods of drought in others. B. Tropical cyclones. ENSO events can influence the frequency and intensity of tropical cyclones, affecting coastal regions' vulnerability. 3. Agriculture and food security. Multi-year El Niño-induced droughts can lead to reduced crop yields, impacting global food supplies and prices. In contrast, multi-year La Niña events may enhance crop production in some regions but also lead to excessive rainfall and waterlogging, damaging crops. 4. Economic and societal impacts. A. Economic costs. The combined impacts of multi-year ENSO events can result in significant economic costs due to damage to infrastructure, increased energy demand, and disruptions to global trade in commodities such as food and minerals. B. Health risks. Changing weather patterns can affect the spread of diseases, increasing the risks of waterborne diseases during flooding and vector-borne diseases during prolonged droughts. 5. Environmental consequences. A. Ecosystems. Multi-year events can stress terrestrial and marine ecosystems, leading to coral bleaching, forest fires, and habitat disruptions. Ecosystems may struggle to adapt to the rapid and persistent changes in temperature and precipitation. B. Biodiversity. Shifts in environmental conditions can impact the distribution and survival of species, particularly those sensitive to climate variations, with potential cascading effects on biodiversity. Conclusion. The findings of recent studies regarding the changing behavior of the water circulation and the potential for more frequent multi-year El Niño and La Niña events are of significant concern. These events can have far-reaching consequences, from extreme weather events and natural disasters to economic, societal, and environmental impacts. It is crucial to recognize and address the potential risks associated with these changes in ENSO patterns, emphasizing the importance of proactive climate mitigation and adaptation measures on a global scale. Thank you for watching. Subscribe to Explanium today and discover a whole new world of knowledge and understanding.